Hello children, today we are going to talk about a very important chapter, and in that we are going to see few points of them, and the name of the chapter that we are going to see is photochemistry. So when we say photochemistry, definitely this branch deals with the study of photochemical reactions, and here we say that definitely the question may come in your mind that how we define the term photochemistry, and here in one sentence we say that it is the study that deals with the study of photochemical reactions, or a branch that deals with the study of photochemical reaction. Then definitely the second point that comes in our mind here is, what are these photochemical reactions? And here we say that photochemical reaction is a chemical reaction in which the reactant molecule may be absorbing the light radiation. It may be the ultraviolet or the visible light, and this absorption of the light will be giving the chemical change. And the best example for this is that if you take the equimolar solution of H2 plus Cl2 in a closed vessel, and if this reaction, if you are observing that particular reaction, there is no change in the reaction in the absence of light. But if you are keeping a lightweight ball on the mouth of that particular bottle, and if you are passing a source of light on it, definitely after a few minutes you will be observing that the ball that is fixed at the mouth of the bottle is being thrown out, indicating that the formation of HCl has taken place. And this example is the best example of the photochemical reaction. And then the most important point that we have to see in this are the laws of photochemistry. So here we are knowing a concept or a law of photometry, that when you are passing a source of light, that time we are going to get a band of colors or a line of spectrum we are going to observe. And here we are observing that how the source of light passes through the monochromator. For example, let us assume that the sodium lamp is the source of light. It passes through the monochromator. What does the monochromator do? It selects a single beam of light of desired wavelength. Then it passes through the prism. Then it passes through the the reaction cell or the sample. And then whatever light is being so some of the light is being absorbed, some of the light is transmitted, and some of the light is reflected. And therefore we say that the intensity of the light I0 is equal to IA plus IT plus IR. But here we say that the intensity of the reflected light is less or negligible, and therefore we say that the intensity of the light is equal to the intensity of the light absorbed plus the intensity of the light transmitted. But here we are observing that in photochemistry we are giving, or we are emphasizing more on the absorbed light. So depending upon this, there are two important laws that we have to learn. Number one is the Grothus Draper's law, and in this Grothus and Draper's law, they have both of them, they have carried out number of experiments related to the formation of HCl by the combination of hydrogen and chlorine. And after conducting or after carrying series of experiments, they concluded that only the light that is absorbed can produce a chemical change. Or in other words, we can say that unless and until the molecule will absorb light, no chemical will change place. So here again, as I told you earlier, that emphasis is given to the absorbed light. And therefore, whenever we discuss about this, that time we have to say that in the Grothus-Draper's law, the importance is given to the absorbed light, because it is the only absorbed light that can bring about the change. For example, here if you consider a general example, A, capital A is the molecule which absorbs one photon of light, that is h nu. A plus h nu, that gives A star or A asterisk. So this asterisk mark indicate that it has gone to the excited state by absorbing light. And again we say that this absorbed light, again it is giving back the products. So in this way we say that if you are making the combination of this, that time we write the total reaction as A plus h nu, that gives A which is in the excited state, and that will be giving you the product. So in this way, this is nothing but we say that by absorbing the ultraviolet and the visible light, the photochemical reaction may take place. For example, here if you go to the theater to see a movie, at the start when we take the seat in the lab, that time it is total darkness. So after some time the light of the projector falls on the screen. So for the time being we can assume that the light of the projector that falls on the screen is the light source, and the screen we can assume that it is the reactant molecule. So as soon as the light will fall on the screen, after a few seconds we will be observing that the characters are seen on the screen. That means we can say that the reaction has taken place as soon as the light is incident on the reactant molecule. So this is one of the examples that we can quote. So with this we will again have a repetition of this Grothus-Draper's law, that this law is giving importance to the absorbed light. And here when we talk about the statement of it, that time we say that it is only the absorbed light that can produce a chemical change. No emphasis is given to the other two parts. It may be the transmitted light or the reflected light. Only the importance is given to the absorbed light. So with this we will stop here only. Again we will discuss the remaining part, the second law, in the next lecture. Thank you.